Welcome back. Session 3, part 2. Still, we are in the domain of observation and exploration of the case in front of us. Let me share with you my screen. You see a cat and you see the food in front. The question we don't know what the cat is thinking, right? But we have lived with cat for a long time. Possibly we could already have some established rule, golden rule. I don't have cats at home, so I don't know that, but I'm going to propose to you a question or perhaps a statement. We have a cat here, and the two dish are going to have, as you can see, different color. The dish itself has a different color, and the food inside is going to be different color. The question is, does the cat prefer red food versus, I would say, blue food? Or blue basically dish? Which one is it? So my statement is simple. I'm going to say cats prefer red food, or I could say cats prefer red dish. Now that's a statement, and the way I'm going to examine it is as follows. I'm going to actually have a sample. I can't sample all of the cats on the planet Earth. It's impossible even to catch them, right? So what I need to do, I need to actually create a sample. What I'm going to do, I'm going to actually go to this pet shop, and I'm going to ask permission from the owner. I'm going to provide food, free food for the cats, and I'm going to give them two separate dish with different colors. And then I'm going to go into a different pet shop, and I'm going to repeat the experiment. And then I'm going to take a look at the results of these two experiments. I see that apparently only on rare occasion, cats seem to go toward the red dish, not the blue dish. My conclusion is now going to be considered a null hypothesis. It means there is no significant difference between these two samples. That's what the null hypotheses mean. Let me give you another example. Once again, this is a cat. Are the cat left-handed or right-handed or pawed, I would say? And basically, that's going to be an important factor, apparently related to their health. So what do we do? So they have paws, okay? So what we are going to do is that we are going to give them a ball to play. Do they basically touch the ball using their right paw, or do they touch the ball using their left paw? And we are going to count that in a duration of 10 minutes, perhaps. But the way we are going to do it, we are going to have different samples taken. I'm going to have, again, possibly I'm going to either call owners of cats or go to a pet shop and ask permission and do that experiment. And I'm going to give them the ball, and then I'm going to see how the cats behave. Now, we forgot to discuss the variable of interest. Now, the question would be, first and foremost, the ball size. Is it a small, important? Is it a large, medium size? What's going to be? The other one is also, as we just barely touched, is the color of the ball. So it's really important to know whether the color is going to have an impact on the left paw and the right paw. Maybe you would say no, because the color decision is made on the eye vision of the cat. So the hands are actually acting irrespective of the color of the ball. You could consider that not an important variable of interest. But you could say this is the ball, and you're going to have different sizes. That's going to be your variable of interest. And what you're going to do, you're going to actually count the paw, the left paw and the right paw, and then see how many times they touch it. That's going to be the output. That's going to be the output. You need to always be conscious of the variables that are going to be of importance in the next experiment. I want to explain another one before I go to the next, and this one is rather easy to basically grasp. It is well understood, and this is what we are talking about humanity and the history of humanity in general. It is well understood that a person is innocent until proven guilty. Why? We had so many times, decades, centuries, thousands of years, where we have been able to examine people of different backgrounds, race, religion, and so on. And we realized that human species do not want to hurt their own species. They don't want to steal. The general public wants to follow the rules and regulations, and put their head down and don't cause trouble for anybody, right? So when you have someone who has, you are suspicious of someone who has stolen something, you're suspicious of someone who is abusive, you're suspicious of someone who may have committed murder, what do? You need to go to the court. When you go to the court, the judge says, this person in front of me is innocent at the moment. The onus is on you to provide evidence or evidences that this person has been stealing, this person has been abusive in a relationship, has killed someone, and basically perhaps violated the traffic sign. The onus is on you to actually prove that. The idea that the person is innocent is easy to actually see the logic in it, because if you go across US, Europe, or anywhere for that matter, and you pick up a sample of 2,000 or 500 or 10,000, doesn't matter the sample size, it's supposed to be small. And if you take a look at that sample size, what happens? You're going to see that these people have are decent citizens, and they don't want to cause any trouble for anybody. And if you go and have different samples, you may come across someone who may have had a speed ticket, if you call it a concern. And then what happens is that if you take a look at these two samples, you don't see significant difference in it. That's why the judge is going to say, I'm going to consider and assume this individual in front of me is innocent until proven guilty. So what is your null hypothesis? Human beings are innocent. What is your alternative hypothesis? Human beings are not innocent. And if you insist on that, you must actually provide, not only in this specific case, but you need to actually have this case examined using the samples that you are going to go and grab. So what's the input? The input is human. That's the input. What's the output? Innocence or guilt. That's the output. That's what we have, okay? Another example. And again, perhaps after a few examples, I'm going to cut my recording and then another few examples so that we understand exactly what hypothesis is. We are going to say people of all ages can learn music. That's my hypothesis. People of all ages can learn music. Now, what I'm going to do, I'm going to actually go and grab samples across the globe, localized geography, whatever you call it. I can't speak for the entire population of 7 billion, 8 billion people, or perhaps even a smaller portion of it where people have learned musics, basically maybe 20, 30 million people anyway across the globe. I cannot have access to that. So what I'm going to do, I'm going to go and find those registered people who have registered for classes to learn music and the grades and the levels that they are. And then what I'm going to say is that I'm going to take a look at the two samples. In one sample, we are going to find 10 years old child, 18 years old teenagers, 40 years old person, 60 years old person, and different kind of a combination of ages in the other sample as well. And you take a look at them and you see apparently they have advanced quite nicely in their level of music training. There are different levels in music training. So then your conclusion is, no, there is no difference. There is no reason for me to assume that a person who is 60 years old cannot learn music. There is no reason for me to assume that a person who is 7 years old cannot learn music. When I take a look at these two samples, it is obvious from the data itself, from the small samples that I see, that there is no difference, no significant difference between these two samples. Therefore, my statement becomes null hypothesis. People of all ages can learn music. That's a null hypothesis. Opposite to that becomes alternative hypotheses. That is, not all people of ages, not people of all ages can actually learn music. You could even pinpoint and say people of above 50 years old cannot learn, people of less than 10 years old cannot learn. So you could potentially create a scenario that is going to contradict my statement. And that's what the alternative hypothesis is. What's the variable? Age. What's the outcome? Learning, the training of the music, perhaps music certificate that the person has. Which one is independent and which one is the dependent one? Of course, the age is going to be independent. You can't go from the certificate you can have and decide what the age of the person is. You can't do that. Make sense? So that's how you're going to, but you could potentially say that and there are different reasons for basically music learning. You could, is the weight of the person is going to have an important variable? No, the weight is not. You could potentially say there is no relationship between music learning and the race. So you need to start with a small number of variables. But in order for you to be solid on the solid ground, you could potentially add more variables, ask questions, exclude them, so that your observation and your experiment is going to be meaningful. Let's try another one. This is actually math, and this is about learning math in different age group. The question would be, can we relate that to the age? Can we relate that? Can we say that all people of all ages can learn math at any age? If that's the statement, once again, you establish some of the samples. We see no difference, no significant difference. There may be some differences, but not significant differences. And that's how we are going to call that a null hypothesis. I want to advance that. I want to say that the gender has no relationship with the math abilities, learning of math. We can say gender. When we say gender, then obviously my samples have to go and basically have a sample, possibly equal distributions of gender in one, possibly equal distributions of gender in another one. Maybe there is a little bit of a difference. Obviously, that's limited to us. We can't do anything. And then decide whether these two have both been able to grasp the mathematics and advance in their career based on their skill set. Make sense? So you need to keep that in mind. And as you remember, as you can imagine, some of the statements I'm saying is I'm actually deliberately, I'm saying no significant difference inside the statement itself. I could. So when I say there is no relationship, there is no significant relationship between variable A and variable B, and that is by its nature is considered to be null hypotheses. Having aspirin and avoiding heart attacks. Another example. Let me finish this and then I'm going to go to another sets of examples. So in future, I might as well ask you to relate to some of the questions and create the hypotheses, the null hypotheses and the alternative hypotheses. And these examples are supposed to open your eyes as to how to begin, what kind of parameters, variables you are supposed to actually consider, what is the input, what is the output, what is the relationship. You need to have that. Now, we say people who took aspirin have lesser chance of a heart attack. people who took aspirin have a lesser chance of a heart attack. I didn't say no relationship. I didn't say no significant relationship and so on. What I need to do is that to examine this. And the way I'm going to examine it, I'm going to examine two samples. I'm going to have a sample where people, for example, I'm going to have 2,000 people. Potentially, I'm going to have 1,000 people who took this aspirin and 1,000 people who are not taking the aspirin. And I'm going to see the heart attack. Then yes or no. Then I'm going to repeat this experiment, this observation with a different sample, different sets of people. Okay, it could be 1,000 taking aspirin and 1,000 not taking aspirin, but still I would like to take a look at the heart attack and see whether there is a relationship there or not. You could potentially say that there are tons of variables involved. Age. You could say, obviously, aspirin and heart attack and age are quite related, as you know. There are cases where there is a precondition. There are cases that the person has had diabetes, and of course, diabetes is a precursor of a heart attack. So the question is, if a person has a diabetes and using aspirin, would they have a heart attack or in a fewer counts or not? Those are secondary. The first one, I made it very simple. The first one, I simply said, did you take aspirin? Did you not take aspirin? 1,000 take aspirin, 1,000 not to take aspirin. The very first experiment I'm doing, and I'm doing this experiment in a tiered way, in a stage way, in a pyramid way, and I'm going to do this first, and I say, I see difference. I take a look at the two samples, and there seems to be a significant difference between the two samples. I had 1,000 taking aspirin, 1,000 not taking aspirin, 1,000 taking aspirin, 1,000 not taking aspirin. And when you take a look at that, you see the data is significantly different. That means you didn't consider all of the dimensions. Another dimension, as I said, is pre-existing conditions. You need to throw that in and then examine again. Maybe it's going to be the age. You need to throw that in and then examine. How about the dose? You need to throw that in and examine again. So as a scientist, you always want things to be simple. Then if there is a significant difference between sample A and B, you need to go back to your samples again, not the same sample, because you don't want the samples to be basically learning what you just did. You need to actually examine different samples of the same size, but that you're going to bring different variables to the table. If there is significant difference, then that's your basically that's the one that you're actually proving. You're going to prove that there is precondition is going to be important in the heart attack, no matter whether you're taking aspirin or not, right? So you need to be very careful on that. Let's stop on this, and I'm going to continue on the observation and hypothesis testing in a moment.